Okay, this is the lab sucrose density. So first in this lab, part 1, the lab is asking, they have given several solutions. You can change the solution, and solution number 1 asking the volume and the weight. So if I go with first one, let me open it. So load the first sample. I am paying attention on these important things. So I load it. So it's one. Okay. Now you see, let me stop it for a minute. You see, this is the balance, measure the mass, and then this is a graduated cylinder which is measuring the volume of a solution. So you see the weight of the empty graduated cylinder itself is 80.4. In this lab, we want to find the volume of the mass of the empty graduated cylinder is 80.4. How do you know? From the balanced reading. And the weight of the solution is what we are looking for. And then volume, because the purpose of the lab is to find the density. The density equation is mass divided by volume, but we need to find the density of a solution. So mass of a solution divided by the volume of a solution. So still we don't know the mass of a solution. So let's see what is the mass of a solution. So when they add water, this side it shows the volume, and the balance reading shows the mass. Still going. They're not stopping yet. I think they stopped, right? So you can see volume. I'm reading from the graduated cylinder measurement, which is 95. Mass is 181.4. But we know this mass is the mass of the graduated cylinder plus water. So, sucrose solution. In order to get the mass of the sucrose solution, you have to subtract the weight of the empty graduated cylinder from this mass. So we know at the beginning we noted the mass of the empty graduated cylinder is 80.4. So in order to get the mass of the solution, you subtract 80.4 from 181. So if you look at the first one, the volume, it is 95. And then mass is basically you subtract 181, and by 84 I'm using my own work. 181, 181.4, I think. Yeah 181.4 minus 80.4, which is 101. So my weight is 101. Now, how do I find the density? Like that, you fill the table. How do you find the, so using that, you can plot the graph. When you add the numbers, it will correctly plot the graph. And then when I'm using only, because I'm doing only for the sample 1, I'm going down and see the density. How to find the density? I know I'm looking only for my solution 1, because that's the only one that's correct. Mass divide by volume. My mass is 101. Divide by volume, which is 95. I'm getting my density as 1.06. 1.06 is my density. And then this is the density and the concentration. They are asking what is the concentration of your solution in part 2. So this is 1 and 1.1, 106 should be in between these two numbers. So the density 1.2, 1.4, 1.06 is here. You go up to the line and go to the horizontally to the y-axis, I'm thinking it is not 20, not 10, it is in between, very close to 20, but I was thinking like it's 16. Concentration is like, I'm just guessing, it's like 16 because I cannot get exact number because it's not a graph paper. This is somewhere between 10 and 20, but more towards 20. So I would say it's number that you can say, but it should be the reasonable number. I'm telling you 16. And then I go down because I'm only doing solution 1. You have to do all the solutions. So look at now. This is the correct ones. So trial 1, the actual concentration is 13, but I am getting my concentration as 16. Calculate the percent error between your predicted and the actual concentration. My predicted concentration is 16 point, I would say 16 minus actual one is 13.47. So then that is the percent error. So this is 4. So if it is my actual one, I'm getting error for like I would say 16 minus 13.47 minus 13.47. Wait a minute. 2.53. Okay, 2.53. So they ask you they ask you percent error. So in order to get the percent error, so I found the percent error equation, which is the actual value minus expected divided by expected into 100. So my actual value is 13. Come on. Sorry, let's go there. Sorry, so my actual concentration is 13. Sorry, actual concentration 16, expected 13.47. Again, expected 13.47. Basically, you get the difference, divide by 13.47, which is 2.53, divide by 13.47 into 100. 2.53 divided by 13.47 to 100, which is 18% error. I associate 18% error. That's what I'm getting for actual error. So for this one, you can pick one solution and you can take your prediction. So I hope this will help you to understand the lab.